Welcome back to PWGC's Environmental Echo. In today's episode, we continue our conversation with Environment One's Chris Nedwick and the low-pressure sewer systems the company develops. If you missed part one, please listen by clicking the link in the description or visiting our website, pwgrocer.com/podcast. Thank you and enjoy the episode.
That's what we want.
You know, something that it's always a concern is what's the thing made out of? So the piping itself, right? You're talking about these smaller diameter pipes, and they're directionally drilled at times, and you know, so that usually comes out of the house. It might be a PVC or some sort of plastic pipe. Then it goes into the E1 chamber, if you will. Is that a fiberglass vault or chamber? And then the pipe that comes out of there and into the road, and then what's out in the road? What are these things made out of?
It's a high-density polyethylene corrugated material.
Okay.
It's not a large structure by any means whatsoever. However, there's sufficient room inside of the tank for storage, right? Wastewater. But it's a high-density polyethylene.
So it's like a plastic type material.
Exactly.
Sure.
And so the actual discharge from the station itself is going to be 1.25 inches, typically poly as well.
Yep.
Say STR9 is pretty common.
Mm-hmm.
STR11, I'm not sure exactly what they're using out here in the system itself. But
yeah, I think it's either one of those two.
Right. But that's going to be poly as well, which is flexible, which lends itself to, working with the vernacular of the landscape. If there's a tree that, someone really likes and they don't want to cut down, leave the tree there and go around it, right, with that discharge pipe. Once it gets out into the street itself, force mains, as Brian said, I would say average between 2 and 4 inches, maybe 6 to 8 inches on some of these systems. But those are HDP as well, typically, or a poly, we'll call them.
And those, they're fusion welded when you put them together, or what does it come in a spool? I mean,
it's usually, if you're directional drilling it, it's usually in a spool, it could be 500,000 feet or more. You have that kind of butt fusion weld there, and you can pull it all through. I mean, that's kind of the big benefit of that. Right. It does come in 20-foot sticks like a traditional sewer, but that'd be way too many fusion welds, and those are not easy to do to make sure you get them right. Yeah. Normally when you're directional drilling it's just a big spool. But again, that also helps on setup and construction impacts, because you got one big spool is right behind a pickup truck versus laying out hundreds and hundreds of feet of gravity pipe that you then got to push together like bell and spigot and roll into the hole.
Yeah, absolutely.
All right. Now I'm not going to throw a softball at you, all right? So Brian and I have been at community meetings, and people, the biggest concern with these,
I've been to a few
you know where we're going with this, is they rely on electricity, right? So they're worried, power's out for a few days, I don't have backup power. What happens with my E1?
So in the case of Suffolk County, these systems are going to be outfitted with a generator receptacle, Gen Auto, right? So you have the ability to hook a generator up to it and pump it out. The service entity typically would take responsibility for that. Any system that's an alarm, they would know about, and you would hook it up to a generator and discharge the station itself. We always go back to making the point that when the average power outage, and I get myself into hot water once or twice with this, because some power outages are quite extensive. I'm old enough to remember Hurricane Gloria, right? Mm-hmm. That was solid 10 days, in some cases 8 days, right? That's all the infrastructure that you can think of has been impacted by that event. It's not just the grinder pump, right? But the average power outage in the United States is 2 hours or less. And that's not to dismiss the significance of that concern in any way, but there's a couple days worth of storage built into these units as well. In parallel to that, we know that when there's no power, water consumption is reduced significantly, right? When the power goes out, you don't take a shower and do 2 loads of laundry and clean the dishes or anything like that. So we don't really see that as a problem. We don't get and really any feedback about that occurring. And, it has occurred, certainly, but it is so infrequent that it's statistically insignificant, basically.
Man, you make it sound so easy, but we had this angry mob in front of us.
Oh, I remember.
They weren't buying it.
Yeah, I think Chris was there for some of those. And again, the generator receptacle helps. The E1 even offers some, I'll say, more sophisticated and advanced controls through their SCADA products that basically would allow a municipality, if you went with that outfit, to run pumps prior to a potential, I'll say, natural disaster. As if you knew a hurricane was coming, you could actually turn all the pumps on and empty everybody's wet wells, so you have the full capacity before that storm hits. And again, under normal circumstances, yes, you're right. I know for Hurricane Sandy, I left my house and went to my in-laws because my house was out for 7 days.
Yeah.
But again, you weren't taking showers all the time. You weren't doing this. And, yes, there are some people that stayed. If you have natural gas, well, guess what? Yeah, you still have got heat. You still have hot water. You probably can take a shower. Well, but, you have a generator receptacle. You can do that. I mean, there's nothing to say that if you lived in a certain area, maybe groundwater came up, tide came up, your septic system may have been overflowing anyway. So while it may have gone out of your house, it may be back in your back lawn, within 6 hours. It's definitely possible. But again, in those longer power outages, we've got multiple failures of multiple different municipal systems.
Oh, yeah.
And, it's just not something you can.
But, I mean, the biggest concern people had were, what do I do when the lights go out?
Sure.
And now I can't use the bathroom or,
Yeah.
Yeah, I mean,
that was...
Again, no, there was definitely, that was probably one of the largest concerns we had with this, and versus a gravity sewer where you would say, well, there would be, I'll say, no perceived impact as long as the regional pump station was up and running and going.
The other thing with the gravities is sewer backups, and we've seen people's houses.
Correct.
Which I assume with these E1s we have check valves, and so even if they're working normally, my neighbor next door can't pump his stuff into my house.
So, and that's a point that I make. If you have an E1 system, you have more protection than you do if you have a gravity system, essentially. For one thing, there's a check valve, but also you have an alarm, right? If that tank goes into alarm, you know about it as it happens, right? If you have a gravity system, you know about it if it backs up into the house itself. But those are all valid points, Brian, about that. But also, pressure sewer is an asymmetric type of infrastructure, right? It doesn't require a centralized piece of infrastructure to function. So if I have power and Brian doesn't have power, my pump still works. Maybe his doesn't, right? But we know in areas that have both gravity and pressure sewer that have been impacted by catastrophic weather events. But we know it's asymmetric in the sense that it's not reliant upon one singular piece of infrastructure to function. If my pump works because I have power and Brian's doesn't, my pump still works. But we also have customers that have both gravity and pressure sewer that have been impacted by catastrophic weather events, and we know through third-party data and information that they were able to restore the pressure sewer quicker than they were able to restore the gravity in this particular case because it was a catastrophic event, and the lift stations were down in that case. And basically with E1, as the power is restored, your sewer is restored simultaneously. And, it was a pretty glaring example of that.
So with a typical E1, say residential application, right, it's a single pump in there?
Yeah, well, typically for residents.
Right,
yes.
right. So
yes.
Then back to, and I know you guys do commercial and bigger systems. What do they have? Are they multiple pumps in there? Or?
So, yeah, we'll go up to a quadplex, which is 4 units.
Yep.
Right. So we say good rule of thumb, 10,000 gallons a day is kind of up on the ragged edge of daily capabilities. We look at flows a little bit differently, too. We don't break it out into gallons per minute strictly like an engineer might look at a larger lift station. We tend to look at what the total flow is for a day. It's expected to be in that application, and we then look at the geometry of the tank and things like attenuation, and we use that to calculate our daily capabilities. But yeah, we'll go up to 4 pumps, but the vast majority of cases, they're there for redundancy, and it's...
That was my next question. Are they all going at once, or are some of them back up in case there's a failure?
Yeah,
or
they
you
can
can set it up in any lead lag and all this fun stuff?
Sure. And we're doing a lot more in the space of multifamily, especially here in Long Island now.
Okay.
And a lot of engineers are specifying duplexes and quadplexes that in the event of some unpredicted spike in flow that's going in that tank, they can turn all 4 pumps on in certain cases without an alarm condition just to get that system normalized again, and then they kind of come out of that mode, if you will. I'm trying to put it in very basic layman's terms.
Yeah, we've done a couple of those designs, I think, with you guys down in Patchogue, because again, we have low pressure sewer there already, so we don't really have an option other than to use a low pressure system to get the sewage into the mains there. I think we did one recently that was 2 quadplexes side by side. Again, and that's using, I'll say, health department guidance and regulations on what we need to size it for. And so we have technically 8 pumps. They're not all going to turn on at once. Yeah. They're really there for more peak flow, and that's like at a 4 times peak factor. So that's kind of like worst case scenario. It's 6 o'clock in the morning in that apartment building and everybody's taking a shower and everybody happens to flush the toilet.
Halftime at the Super Bowl, Brian. That's coming
exactly.
up.
Halftime at the Super Bowl. We're there. We're fine. Like it works. Under normal circumstances, we'll probably have 1-2 pumps running. And like you said, Paul, they lead lag. Those quadplexes are set up that one pump turns on when the pressure transducer gets to the next spot. Pump number 2 turns on, then 3, then 4, then the high level alarm.
Then the alarm.
And then, but usually even then you've got a minute or 2 to let it run down. And if it satisfies itself, the alarm goes away and we start to drop a pump as we go back down again.
And not to jump all over the place here, but just as Brian was talking, it made me think of a question that you had earlier. In those public forums, we do get the vast majority of people are very grateful to have sewers. That's what we found. However, there were some folks maybe that had some concerns. I talked to people who said I can't take a shower when the tide comes in, and I have $1 million home, and I won't say where it was. So they're kind of, I don't want to say chomping at the bit, but I think very welcoming of this development of finally having some centralized collection here in Suffolk County. But the other thing is the standard product that we provide here in this market has what's called a Protect Plus panel, which is going to protect the asset from overpressure, brownout conditions, and things like that. But what I'm getting at from the homeowner's perspective is it also has remote monitoring and alarm capabilities. So if there's an issue and a pump system does go into alarm through a modem, so a cellular signal will be sent out through a modem, and the service entity will be made aware that there's a problem, and they can be dispatched, to fix it, oftentimes before the homeowner even knows there's an issue. So that's
like the pumps and stuff like that. I assume they're stock items. We normally, like Suffolk County, the DPW, or whoever's going to be responsible for these repairs or maintenance, they'll have a whole, I don't want to say warehouse, but a storage facility where they've got these things sort of on the shelf. Yeah,
and that's another aspect of our approach to the system itself. We want to keep operation and maintenance costs, what we call O&M, as low as possible. So standardization, simplification. If there's a municipal director or manager, we don't want them to have 3 different types of pumps on the shelf because they don't know what they're going to get when they show up and pop a cover. So we make one pump, and where the variation occurs with our product is with the tank and the panel itself, but the pump is the same. So what that translates to in terms of cost of ownership is it reduces it because you have one set of parts, one set of training, right? You have one type of a pump that is we'll call it a spare, right? So lots of different ownership models and very flexible in that sense. But if it's 2 o'clock in the morning and someone has an alarm call and the service entity decides that, it makes sense to go there at that moment and address it, they can simply take a core out, what we call a core as a pump, put a replacement in, and that's a 15-minute process, right? Maybe the next day they can go back and do some troubleshooting to find out what happened. But yes, standardization is key. We want to have that type of repeatability is essential to keeping costs down. So yes.
And so you mentioned, back in the 60s when this stuff started to get developed, I mean, the pumps, if I went back to one of your original systems for the pump today, it'll still swap out just as easy?
100% reverse compatible. And that's another, it kind of feeds into that concept of keeping O&M costs as low as possible.
All right.
We have a lot of installations out there that were installed when Richard Nixon was president and, going back 5+ decades in some cases. You could take one of those assets out now and replace it with a pump that was manufactured today, and it would work seamlessly. If the tank is still good, keep the tank, use the tank. There's no need to create costs where it's not warranted.
Were those original tanks, were they also HDPE plastic?
They were fiberglass back in the day, kind of a cup type of configuration where they were stackable, if you will. But a lot of those are still out there.
That's
working.
What I'm wondering, yeah.
Yeah, a lot of them are still out there working. But we are very excited about what's happening here. You hear the horror stories about decades ago when, this was attempted before. But again, a point that you made in a previous podcast, you could tell I did my homework. There does seem to be political leadership in place that really wants to solve this problem. And it's very open-minded and I think there's an understanding in the community that, hey, we need to fix this problem and we need to do it now for future generations. So we're excited about that. We feel like we're going to be a key stakeholder in that process.
Well, we're looking forward to it for sure.
Thank you.
So you mentioned a couple of projects like the Forge River and Patchogue. What else do you have going on regionally that might be of interest to our listeners?
Absolutely. So in this market, we've got what we call the Suffolk County Coastal Resiliency Initiative projects. There are other pockets of pressure sewer that are being evaluated in places like Oakdale, right? That one I know is very familiar to you guys. Other places like Great Neck are looking at it over in Nassau County. Out in Riverhead, we have these systems, places like Northampton as well. There's ongoing work taking place in Patchogue. But when these SCCRI projects come to a conclusion, the hope is that there'll be a pipeline of future expansion and development as funding becomes available and things like that occur. And, we view it as our job every day to, help make this process as positive as it can possibly be for every stakeholder, for the community, the engineering community, the end users, the homeowners, and we want to create the continual impression out there in the marketplace that this is the best way to go about solving this problem.
So, a question for both of you guys, and you just got me going again. You talked about future development or connections, right?
Right.
So let's say we did put something in Oakdale, and then all of a sudden, West Sayville or Sayville want to tie in. How much future capacity do we design in right now, and still be cost effective?
In terms of the piping
network?
network?
Let's just say the pipes, the out in the roads, the laterals, the mains, all the big stuff that's got to get its way to a pump station or Bergen Point or whatever. How much do we typically look to put in now for the future, if at all?
Very scalable technology. The pipe sizing themselves, the pipe sizing process itself, I should say, has a lot of reserve capacity, right, for connections. But there may be instances where there are parallel pipe networks installed as well. And one of the beauty of the small diameter nature of the technology is that that's a process that can be done efficiently and doesn't have a lot of impacts on the community. So if it turns out that there's not enough reserve capacity to achieve future objectives in terms of new connections, parallel networks can be installed very efficiently as well.
Yes. And then like that, for example, that was Main Street in Patchogue. When they knew they were gonna expand to East Patchogue, I think they ran dual 3-inch lines down Main Street.
Right.
And basically they were valved off that they ran line A first, maxed out that capacity as they added more units on, and then switched over and opened up the valves to run line B next to it.
Yeah.
So you kind of had that. They put them in at the same time because, again, cost-wise, it was, in essence, one directional drill. They were pulling 2 pipes at the same time, and it made it just, you had that kind of extra built-in capacity. So, again, if we're designing and we know that we're going to be tying in other things even in the near future, maybe at key points it makes sense to run duplicate lines. Or like Chris said, we may have to be able to, you could probably add another line in if we needed to kind of move it around. Because, again, it all matters. It all kind of depends on where our endpoint is. Right now we're relying heavily on Bergen Point for a lot of these. But Bergen Point has a lot of capacity, but eventually we're going to tap that out. And now we're going to need to go somewhere else. Mm-hmm. But, I think we have some definite expandability in there. And I think that with the Carls River project moving forward, Forge River moving, that once these projects are kind of built and established and show that this has a new track record, that this can be done, it's done effectively and efficiently, that hopefully we can kind of keep the ball rolling and get more of this going on in the county. I know that's definitely the push from the county executive and the political side of things want to make that push because, again, we see it, kind of going back to some of my prior thoughts, but environmentally we see it. We're all now accustomed to, Chris Gobler's annual report on water quality for the bays and everything. We see that, nitrogen and a lot of other things are causing algae blooms and causing things to go awry. And, while sewers aren't directly related to, climate change and warming of waters, but we haven't had peconic bay scallops in how many years now? 3 or 4?
Yeah.
That we don't have them anymore. So, you kind of see that that's really the real drive for this. And I think everybody kind of sees that.
What we see, too, and just to kind of expand upon what Bryan just said, you get a lot of bolt-on or additional connections that take place, particularly from the business community. There may be a restaurant that can't add tables because they have a cesspool, right? Water in, water out. If you don't have enough treatment capability, you don't get to grow your business, right? So there's a lot of what we have noticed is that where these force mains are installed, it kind of nurtures further, I don't want to say unanticipated, but new connections that may not have been part of that project proper initially. And in places where you do see collection here in Long Island, and particularly we'll just go back to the Village of Patchogue that has an E1 system. I mean, all you got to do is drive through there on a Friday night and see,
how vibrant it is,
economically. And, we've seen the power of this technology to change communities overnight and really bring in investment and confidence and help expand the economy, create jobs. All those things really starts with infrastructure. So that's kind of the way that we look at what we're doing here. We have that sense of higher purpose.
That's great. Chris, I don't want to take up your whole afternoon, but I do have one or two more questions for you, and we do appreciate your time. You've worked on these projects all across the country, not just here on Long Island, right?
Yeah.
What are some of the biggest hurdles you see to the implementation of these systems? And what do you do to get over those or around those hurdles?
So a couple different things. Funding is number one, and I'm not just trying to preach to the choir here. With the amount of money we spend in this country on just stuff, I think we can all agree that we should probably be allocating a lot more for wastewater and water infrastructure. So funding is the number one obstacle. But let's assume there is a project in place. We want to make sure that the installation is done properly. So we do what's called certified installation. We're doing that here with the Suffolk County projects, spending a lot of time with the contractors, making sure that they're using certified practices. We have mobile apps and things like that basically are used to measure the quality of the installation. So we want to make sure the install is good. We want to make sure that the public is informed and educated. We find where there's a lot of pushback, it's just simply fear, doubt, and uncertainty. So that's why we do things like this. We do lots of brown bags and educational events in places like Suffolk County and other places every week, every month. So education, funding, and we want to make sure once the system itself is implemented that it's installed properly, because we want it to last as long as possible. We don't want it causing problems for end users whatsoever. That all starts with a good design, but also a good installation as well.
Fantastic. Bryan, you have anything you want to add before we wrap up?
No, I mean, I think I'm good. I think Chris kind of covered it. I mean, again, I think it's one of the options we have in our kind of toolbox to make this work. And again, it's been used all over the country. I know Chris has done some work in Florida, and it's, kind of similar to us. It's a little bit warmer down there in this time of year, but, similar environment.
Sure.
And again, we've had E1's had large scale successes across the country. And we've seen the white papers. We've talked to some of the O&M providers, and their E1's good at getting those guys kind of back out on the road show and bringing them to new municipalities to even educate the municipalities on what happens and how it goes. Chris talked about replacing pumps. I mean, I've seen the E1's reps replace a pump in probably 2 minutes.
Yeah.
I mean, I've watched it and went, wow, I could do that. Whereas, more traditional pump stations, I'm not going to be able to do that myself. But you can, and that kind of goes to how smooth of a ride it's going to be, long term.
Yeah, I appreciate that. Once upon a time, it was considered an alternative technology, rightfully so. It's an appropriate technology now. With 850,000 systems out there, I think some estimates 2.5 million people every day using an E1 system, going on 54 years of experience with that 25+ year service life. It's an appropriate technology that we feel is going to be used on a much larger scale in places like Suffolk and Nassau County and beyond.
We are, as a Suffolk County resident, I'm looking forward to it.
It's great.
Chris, do you have anything, last thoughts or comments you want to make before we wrap up for the afternoon?
Sure. No, I mean, it's great to be part of this podcast. As I said before, Paul, it's you guys make it all about the community and not just about any one thing. And these are issues that we need to talk about in order to solve this problem. And it's going to be a long-term endeavor, but I just think it's great that you guys are out there spreading the word and raising awareness. So thank you for the opportunity to be here.
Thank you, and thank you for joining us. And again,
Absolutely.
our guest today was Chris Nedwick, National Sales Development Manager with Environment One,
Thank you
or
for
E1
that.
as I like to call them, Environment One Corp. And we also had Bryan Grogan, our Senior Vice President of our engineering unit at PWGC. And again, folks, I'm your host, Paul Boyce, the President and CEO of PWGC. And I just want to thank you for listening into the Environmental Echo. And again, to recap, if you guys want to reach us, the best way to get a hold of us, I say it all the time, our website, www.pwgrosser.com/podcast. Any thoughts, comments, ideas, or future topics you want to have us discuss, we're open to hearing from you. We do appreciate your time today, and we look forward to you guys joining us on our next podcast.